We're going to look at special triangles, including a 45-45 and a 30-60. And then we're also going to take a look at reciprocal ratios. Some angles we use over and over and over again. And that's why it's important to know the exact values for their trig ratios versus a rounded or approximated number. So the special angles that you need to know are 30, 45, and 60. So this is the reason why we look at exact versus approximate answers. So if you were to plug in sine 60 into your calculator, you would get 0.86025437 . And then versus on where you round, you could get different answers. It could be 1, it could be 0.89, it could be 0.87, it could be 0.866. So those are all kind of very different numbers. Versus if you use the ratio and the exact values, which is the square root of 3 over 2, that's going to be the same. There's no rounding, there's no error in the rounding. It's always going to be the same number. So that's why it's important to know exact values when possible versus approximate answers. So this is how we get our 30-60 triangle. It starts with an equilateral triangle where all three angles are all 60 degrees and all sides are the length of 2. And so what you do is you draw a perpendicular line from one vertex and draw it straight down and bisect the other side. And so what happens is that you would create two triangles, and those two triangles end up being 30, 60, 90, because these two angles end up being 30 because they got bisected. And then also down here, this length of 2 got bisected, so this length is 1 and this length is 1. So now that we have that split up, we can use some Pythagorean theorem to solve for this other leg. So remember, 1 squared plus b squared equals 2 squared, which means that this length right here is the square root of 3. And then we use our trig ratios. Sine is opposite over hypotenuse, so sine of 30 would be 1 over 2. Cosine would be the square root of 3 over 2. And then tangent would be opposite over adjacent, so 1 over the square root of 3, which we know we need to rationalize that, so we end up with the square root of 3 over 3 for tangent. Go ahead and look at the 60 degree. So here's our 60 degree. So opposite is the square root of 3 over hypotenuse is 2. So that's sine of 60 is the square root of 3 over 2. And then we have 1 over 2 because that's adjacent over hypotenuse for the cosine of 60. And then we have the square root of 3 for tangent because that's opposite the square root of 3 over adjacent 1. So the square root of 3 over 1 is just the square root of 3. So this is how you can use the 30-60 triangles. So the 30-degree angle is always going to be opposite the shorter leg, so the 1. And the 60-degree angle is going to be opposite the longer leg, which is the square root of 3. And then the hypotenuse is always going to be twice the amount of the shorter leg. So if the short leg is 1, then the hypotenuse would be 2. And then the long leg is always going to be the square root of 3 times the short leg. So if the short leg is 1, then the long leg is the square root of 3. All right, so using those hints or using that information, we can find A. So knowing that this is a 30, 60, 90 triangle, we know that this is across from 30, which means that it's the short leg. And remember, the hypotenuse is twice the amount of the short leg. So if the hypotenuse is 8, then that means the short leg has to be 4, which is option number 2. We can look at this one. This one is side B, which is across from 60 degrees. So we know that side B is the long leg, okay? So remember, the long leg is going to be the square root of 3 times the short leg. So the short leg is 5, which means that side B, the long leg, would be 5 square roots of 3. Now let's go on to a different triangle. This triangle is a 45, 45, 90, which means it's an isosceles triangle, where both of the angles are acute and they're both 45 degrees, which means that they are the same, which means that the legs are also going to be the same. And then that means you can use the Pythagorean theorem to find the hypotenuse. So, using the Pythagorean theorem, we can know that our hypotenuse here is going to be the square root of 2, because this is 1 squared plus 1 squared equals hypotenuse squared. So, that means that the hypotenuse is going to be the square root of 2 here. And then we use our ratios. So, sine is opposite over hypotenuse, so we get the square root of, we actually get 1 over the square root of 2, because that's 1 over the square root of 2. Then we rationalize it, and that's how we get the square root of 2 over 2. And then cosine of 45 is going to be adjacent over hypotenuse, which means that it's the same thing as the sine. In this case, only because the legs are equal. The adjacent and the opposite are both the same value. And then tangent of 45 is opposite over adjacent, which is 1 over 1, which is just 1. So those are the exact values that you'll need to know for the sine, cosine, and tangent of 45. So these are the rules. The lengths are equal, the legs are equal in length, and the hypotenuse is just the square root of 2 times one of the legs. So, for example, if I know this is a 45-45, and I know that I have a leg, remember that the hypotenuse is just the square root of 2 times the leg. So 3 times the square root of 2 times the square root of 2 is 3 times 2. Or, sorry, 3 square roots of 2. So it would be 3 times 2, which is 6, for the hypotenuse. But I'm sorry, it actually asks to find A. A is the other leg. And in a 45-45 triangle, the legs are the same, which means that if this leg is 3 square roots of 2, then this leg is 3 square roots of 2. So to find C, which is the hypotenuse of a 45-45 triangle, we would multiply the leg by the square root of 2. So 7 square roots of 2 times the square root of 2 gives us 7 times 2, which is 14. Now we're going to talk about reciprocal ratios. Remember, reciprocal is just taking the flip of the ratio or the fraction. So cosecant cosecant has the abbreviation CSC. So cosecant is the reciprocal of sine. So cosecant would be 1 over sine. And then secant, which is abbreviated SEC, is a reciprocal of cosine. So it's equal to 1 over cosine. And then cotangent is the reciprocal of tangent. The abbreviation for cotangent is COT, and so its ratio is going to be 1 over tangent. So the ratio for cosecant, since sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite, since it's the reciprocal or the flip. And since secant is the reciprocal of cosine, cosine is adjacent over hypotenuse. And so if you flip that, you can get the secant, which is hypotenuse over adjacent. And then since cotangent is the reciprocal of tangent, and tangent is opposite over adjacent, that means cotangent is going to be the flip of that, and it will be adjacent over opposite for cotangent. So let's use some of this information. So if, let's say, we want to find cotangent of 35. So remember, cotangent is 1 over tangent. So to find cotangent, we would do 1 over the tan of 35. Rounding to the nearest thousandth, we get 1.4281. All right, now cosecant of 30, which would be 1 over the sine of 30. And if you remember, sine of 30 is 1/2. So 1 over 1/2, which is 2. So then we have secant of 45. So secant is the reciprocal of cosine. So we get 1 over cosine of 45. And then we round to the nearest thousand, and we get 1.4142. All right, so here we are going to solve for an angle using reciprocal ratios. So let's say we have cotangent of A is equal to 0.577. So we're looking for what angle, when we take the cotangent of it, gives us 0.577. So the first thing we want to do is we want to rewrite cotangent as a reciprocal of tan. So cotangent is the same as saying 1 over tangent. So we get 1 over tangent is equal to 0.577. So the first thing I'll do is I'll multiply both sides by tangent. So then I get 1 equals 0.577 times tangent. Then I'll divide both sides by the 0.577. So now I have tangent is equal to 1 divided by 0.577. And then remember, to undo the tangent, I have to do the inverse tangent, or the arc tangent. And so arctangent of 1 divided by 0.577 and rounding to the nearest degree gives me 60 degrees. All right, let's do another one like that, secant. So the first thing we want to do is rewrite secant as a reciprocal of cosine. So it becomes 1 over cosine. Then we'll multiply both sides by cosine. So we get 1 is equal to 2.593 cosine A of angle A. So then now to solve, we'll divide both sides by that 2.5593. So cosine of A is equal to 1 divided by 2.5593. And then to undo the cosine, we're going to do the inverse cosine, or the arc sine. So angle A is equal to the cosine inverse of 1 divided by 2.5593. So using our calculator and rounding to the nearest degree, we get 67 degrees. All right, that's all I have for special triangles and reciprocal ratios.